On to question 7. Draw the structure of the neutral product formed in the following reaction. Okay, so we have a compound here that contains 2 ester groups. And you'll also notice this methyl vinyl ketone. And then they also react with methanol. So let me just draw out our first reactant. Okay, so the role of the deprotonated methanol is that it acts as acid or a base, sorry, and it deprotonates our starting product. Okay, so once it takes the hydrogen, the electrons move here, and then there is a negatively charged oxygen. But if I were to draw this structure to show how the charge can be stabilized, it will look like the following. Since realistically the negatively charged oxygen doesn't just stay on the one oxygen atom, it will kind of look like this. And it's kind of shared in between both. Okay, so I'll just write that step 1 was the deprotonation. And now what happens in step 2, let me draw the second reactant up here. Move it over a bit. Okay, and it also contains a carbonyl functionality. So this negative charge comes in and attacks the carbon. And then I'll just draw the movement of electrons going up like that. So this step is the nucleophilic attack. So the nucleophile reacts with the electrophile. So this is also can be called conjugate addition. Okay, so moving on down, I'll draw what this structure looks like after that second step. And I'll also show the new bond that was formed right here. So now we have a negatively charged oxygen and a new double bond formed here. So I'm just going to draw another molecule of methanol. And I'll show that this negative charge comes down. This double bond gets reduced. And then we are left with our final product. So just to complete all the steps, step 3 can just be called proton extraction or abstraction maybe. All right. So let's see what the junior tutor said. The given reaction is the reaction between dimethylmalonate on the left and methyl vinyl ketone on the right. Here, the alpha hydrogens of dimethylmalonate are considered extremely acidic. Hence, once deprotonation occurs, the conjugate base is balanced out by 2 carbonyl gatherings. So this is shown here in step 2. Because of this, a base in the form of methanolate deprotonates the acidic hydrogen of the dimethylmalonate, producing an enolate. After which a 1,4 assault or Michael assault occurs to the ketone, giving a final product shown below. Yep, so this solution is correct. I think they just forgot to put the 2 oxygens at the top there, but I'll just make a note of that. But the solution is still correct. Yep, so the explanation was correct. I just added that the 2 carbonyls in the dimethylmalonate should still have its oxygens in the final product.